with the Podman utility for Linux. That does involve, wait a second, let me set my settings to where they're not so magnified. That does involve installing Podman. Who has installed Podman? It's a relatively simple operation. If you have not, I'm prepared to walk you through that at the beginning of this.
I haven't done it.
Okay, fantastic. Sorry, I have a 4K monitor, so I turned the font size up to double.
Right.
So when I hook up to the overhead
4K.
projector, I've got to tune it back down. All right, that's almost human looking. So what distros are we dealing with here?
I've got Ubuntu.
Ubuntu? Okay. And yourself?
Debian, so
Debian. Fantastic. Okay, well, we'll start off with the Ubuntu one. So Debian, you should just be able to do a sudo apt-get -y, install Podman. Okay, and then for Ubuntu, I think it's very similar. Although you might have to update a bit in order to make sure that you read the last version of Podman. Let me know when Podman is installed. Okay. Go ahead and type Podman at the command line and see if you get an error message that you somehow ran it without enough arguments.
Okay, so what we're doing?
Podman?
Okay, oh, just Podman? Okay.
Yeah, just type in Podman just so it can basically say something between command not found or you typed in the wrong arguments.
Yeah, it gave me a whole bunch of options.
Okay, so then it's installed.
Yep.
We'll wait.
Looks like I'm having a problem with my package.
Sure. Let's take a look.
Alright. This says unable to locate package file. But I know I have never connected.
All right. Are you running as root? Do a
No.
yeah. Do a sudo space su space dash. Okay. Now do a sudo apt-get -y. Not a sudo, just an apt-get -y. Podman. I'm sorry, apt-get -y update. Okay, now change that -y to install Podman. Okay, which version of Debian are you? Which version of Ubuntu are you using?
18.04.
Okay. You need to upgrade to 20.2.
Ah.
So if you can launch, was that a VM that you were running it in?
Yeah.
Okay, so if you can see if you can get yourself a 20.10 VM, we'll pick up and then you can just sort of wave me down and we'll make sure that you've got Podman.
Okay.
Okay, so who remembers what we had talked about Docker and the layered file system?
I wasn't here. But I'm sorry.
All right, well, it's only the third time I repeated. I can do it one more time. It's not that
Well,
big of a deal.
No, we don't, we just.
Yeah, I can pull instructions.
It's not, if he's going to be running commands, he needs to understand what he's going to be doing, otherwise it's just typing in. So there's a layered file system that is part of the containerization. Are you familiar with containers a little bit? Are you familiar with the layered file system? Okay. You basically, your image contains every layer, okay? And they're all immutable. Can't change them. And then when your image runs, which means that you have a container now instead of an image, you get a read-write layer on top. And if you remove something, it actually just removes the inode in the read-write layer. The lower containers still have it. If you add something, it's added to the read-write layer, so on and so forth. So this is kind of important because when we talk about making a new image, then what we're going to do is, it depends very much on whether we're making a base image, that we're basically trying to do the lowest layer of the layered file system, or if we're taking an image that already exists out there, and we're trying to add a layer on top. Okay? And a good example of a scenario where you might want to add a layer on top is you might want to, say, add a different web page to an already built web server image. Okay? And a good example of where you might want to, say, create a base image would be if you wanted to basically package up a little mini distro version, sort of like Alpine Linux or something like that. Okay, so. So these are the concept of the Docker image and the layered file system. Let's see if I can get it small enough to get it on the screen.
This is what you were talking about last week?
Yes. So you see, we actually have 3 containers running. Okay? And I know that last week I showed you the layers respective of each image.
Mm-hmm.
But since these are actually all 3 containers of the same image,
Right.
and since the lower layers are immutable, they'll just share the lower layers.
Ah,
Okay, so that's one of the ways in which it's going to take some space. And so here's the writable layer. It will change the writable layer, and then if you're looking for something and you can't find it in the writable layer, then it just keeps going down through the layers until finally you get, to either a file not found or something else. Okay, to build a Docker image, you start off with a Docker file. And these instructions are going to be a little bit different than our Podman instructions, but they should be compatible because Podman makes the Linux environment compatible with Docker commands. That's what Podman is. It's a command translator that translates any Docker command into something equivalent for Linux. That means that if you really want to get into it, your container is not running in any of the ways that it's saying up here. It's running on container D, okay, or it might be running on there's some sort of open container API interface in between it called OCRI or something like that. I can't remember what it is. But the point is we'll be using Podman commands every time where we would normally be using Docker commands. Okay? And so you see this Docker file here? We need a Docker file. Go ahead and make a directory so you have a clean working space. Go in there and touch a Docker file. It is important that it is capitalized with a D. How you doing on the VM?
I'm getting there.
All right. Well,
I'll get it.
you're not falling too far behind. All right. So, because all of the images usually start from another image, the first line that we're going to put inside this Docker file is from. And what we're going to do is we're going to pull the image node :10-alpine. Hopefully that one's still available. And then we're going to have a working directory, user source app. And you'll notice that now we're copying items into it. We don't have these package files or this .json or everything else, so you're going to make a file outside of the Docker file, like a test file, could be test.txt or whatever. And then you'd say copy test.txt. You can run commands inside the image if they're available. And you can do other copy commands too. Let me see if I can find one that's actually, let's see, package, web page. Okay, but I know I started you straight off. I forgot to do something that's very important. We need to make sure that your Podman environment works. Okay? So type in Podman run hello-world. Okay, so the only thing that's really unusual about this is remember that containers are processes, but they're processes that are in a jail that basically prevent it from interacting with the system. Standard out still wires back to whoever ran the command. So this printing statement, this statement that is printed, came from inside the container, printing out to the standard out. Okay? That container could not read your file system in a normal sense, but it can at least print to the screen. How you doing?
Slow.
Isn't it always when you need it?
I don't know.
Does it
So,
show your percentage update or?
A window popped up saying that the update was ready, and I entered my password, and it's just not showing any progress.
Oh, because you did it through the GUI?
Right. I mean, it's right there. I thought it would leave the GUI up. I usually do it.
And if you run into locks saying something else is running it?
No. Maybe.
Okay, so you're updated. So go ahead and do.
So it says it, but it.
Well, that status bar is very little to do with anything else. That's
Oh,
all
it
that
is.
matters.
No, you're right. It is.
Okay, so go ahead and do install.
Dash get install or -y install copy.
If you don't do the -y, just say yes every time they ask you a question.
There we go. Unable to locate package.
You sure you're on 2010? space / etc start release start.
Start with this.
You're on 18 still. You probably need to launch a VM on a new
Do a new one?
VMDK. You'll probably have to like download the ISO for it.
Cool.
Do you have Podman installed?
I think I do not.
Type in Podman on the command line and see what happens.
No.
What distro?
Ubuntu app install Podman?
If you're 2010, yeah. If you're 18, you're SOL.
2204?
Oh, that's,
I know it's in 2210, 2204 it might have it. Try an apt-get update and then an apt-get install Podman. Are you familiar with containers?
Yep.
Okay.
I am excited about creating let's see.
See, you're the most prepared.
You might have to, if he wants to use the team report, you might have to add some reports. Or do the upgrade thing.
Yeah, that's a good point. There are ways to add in extra repos to pull Podman into 1804, but I would prefer that you actually just use a modern operating system.
so 20.04 is preferred?
Why don't you just go to the Ubuntu webpage and see what the latest is? Are you familiar with Podman?
Oh no, Kai's gonna show me something about his algorithmic trading, so.
22.04 is what it is.
That's the long term. The 22.10 is actually the latest.
I always do the LTS.
Okay, that's fine. Should be fine.
1804 expires in a month,
I'll try
right?
20. I'll try 22.10.
No, I think it had about 20 years of support on it. It still runs Linux kernel, 1.2.
Which one?
I think, yeah, 1804, it's supposed to be like, it has support until like April, right, of this year?
Oh, is it this year?
Yeah.
1804 has been around for a long time.
Wow.
Probably around, yeah. Did you get your Podman in, Marco?
It's installing now.
Awesome. Did you guys do anything silly like add in an extra?
I stopped using apt-get. I don't know if there's a difference.
Probably a difference. Probably isn't a big enough difference to worry about too.
Could not execute systemctl. Is the systemctl?
You can run Podman container. On Ubuntu, but I do know that Podman's own instructions indicate that you should use.
It says the server's running fine.
prints to standard out. Hello from Docker. Pod can't launch, then not pod.
Alright, so.
Okay. So there are things called Docker registries, and there's a number of them available if you want to host your own. What we're going to do next is we're going to pull a new image from the Docker registries. You can do a a Podman pull BusyBox, and that'll pull BusyBox in. BusyBox is basically an executable that was designed, I think, by Mad Dog. Maybe it was by Cox. Anyway, it's one executable that implements like 90 of the Linux command lines, so you can use symlink itself, and whatever it sees, whatever name you ran it as, and then that way it'll know which command you want it to run. It's called BusyBox because it implements 90 things in one executable, and it was built specifically to be very small. Did you get it pulled?
Yep.
Awesome. So now if you do Podman images, you should be able to see that you have pulled BusyBox. Of course, you just have the image. It's not actually, a running container. So you can run it with Podman Run. BusyBox. And when you run BusyBox, you're going to notice that it closes right away. Because basically, if you run a shell with no command, whatever, it's just going to finish. So what you need to do is you need to provide it with some options in order to actually do something. And in this case, it will take the parameters here and it will treat it as a command within the container.
So you're sending a command to the container, and the container sending it out to send it out.
Right.
The container is running it as bash or whatever BusyBox uses, or BusyBox is its own, is an alternative to bash.
BusyBox is like its own. It's got its own shell. It's not as fully featured as bash, but it's a shell. The main thing is that when you're running it this way, your command is inside a gel. So if you wanted to, you could run this command with a touch, like to try to create a file, and you'll notice that your host operating system, no file exists, even though it reports it as created, because it's using the layered file system.
I saw talking about layered file systems.
Do we need to cover that real quick? It's not overly complicated.
I remember you saying that like you can create stuff with a layered system on the top, but those changes would not get saved into the image.
Right. So when you run a image, it creates something called a container. A container is a running image. And the big difference between the image is the image has got all the immutable layers, but the container has a writable layer on top of it. So if you were to touch a file inside the container, it gets touched into the writable layer. And when your container exits, it gets lost. And so you're familiar with BSD gels and C-pounds, gel shell. This is sort of like that on steroids. We catching up?
Starting the install process.
Okay. All right. And I mean, different images will have different kinds of options that can be passed in from the command line, things like that. So if you do a Docker PS, it will show you all of your Docker processes. I'm sorry. If you do a Podman PS, it will show you all of your container processes. And you don't see any, so you might need to expand it a little bit by doing a PS-A, and then that way you really do see not just the processes that are running at this instant, but also the processes that completed.
Wow, they should see everything.
So let's try launching an interactive container. What this will do is this will wire your standard input and standard output into the container, such that when you run the commands inside the container, you'll be actually have a live shell that you can type in, and when you exit the shell, you'll exit the container. The -IT is short for interactive, so I think the I is interactive and the T might have to do with routing and input and output, but I've forgotten. But you'll notice that what we do is we're running shell instead of running echo like we did last time. Let me know when you're in the container. All right. For fun, touch a file. Make a file in a directory that you know really exists. Then open up a new terminal and go take a look at it. Notice that it doesn't really exist outside of that container. Very limited shell. It's a very limited set of commands. So you're not going to be able to do the command that you're probably used to doing, but you'll be able to do, you know, some basic shell script. In the shell. What's who am I saying? Or ID.
Yeah,
Okay. Go ahead and remove the var log directory recursively. Inside your Docker container, please.
I'm afraid.
Control-Shift plus, sometimes it zooms in if you're using the terminal if you can't see.
No, they can't see our log in the switch directory.
Okay, CD/var.
No.
Oh, okay, it just doesn't have a var log to remove. Well, then remove. underlying operating system is getting around with, because you're running containers. And the containers, you're trusting in the layered file system to keep the operating system from getting changed. That means that you can change inside your container, etc password. You can add users to it. It will not allow anybody to log into your operating system, because that's not the one that's inside your operating system. It's just a copy that's in that read-write layer of your running container. Did you catch up?
I'm getting closer.
Okay. You know, I'm trying not to go too. Make sure you get there. All right. Yes, sir.
If we have time, if you ever see opportunities to mention the differences between these Docker containers and virtual machines.
Certainly. Docker containers are processes. They hold process entry in a process table. They do not emulate. Use the same hardware. So in other words, there's no such thing as switching onto the CPU. Like virtual machines, you know, it'll swap the whole operating system onto the CPU and swap an operating system off the CPU. And that's how the virtual operating system gets a couple of clock cycles. Okay? This is not what happens with Docker. With Docker, your regular operating system's process scheduler decides who gets more, you know, a couple of CPU cycles.
So it sounds like it's more direct to the CPU.
Right, well, no. When an operating system gets swapped to the CPU, literally the operating system that used to be running, the one that's your host,
Right.
stops. It gets everything saved off into RAM,
Okay.
okay? It unloads all of the registers of the CPU into RAM, okay? It then sets a timer that says, in so much time, or on certain events, reload all this stuff on the CPU. Okay? It's like an interrupt.
Right.
Okay? And then it says, now let's load this other operating system onto the CPU and everything else. And as that operating system is running, eventually the timer will get, the trigger will get called to unload that operating system. Okay? Which also stores all of its stuff into RAM or on disk or wherever it's going to store it. And then the old one gets loaded on. And the old one would not know that it was paused unless it checked the system clock. Because you've got a hardware clock with a battery in it. And that's the only thing that it'll notice. It's like, oh, you jumped ahead a couple of seconds, or a couple of milliseconds, or whatever. And so this swapping on and off means that in a virtual machine, your process is running inside its own operating system that really does touch real hardware.
Oh, right.
Okay? The difference with this is that containers share the same operating system. That's a heck of a lot less to swap in and out.
They never have to swap out the operating system.
Bingo. So that means that containers is just context switching between processes within an operating system. Whereas VM setups, it's swapping between whole operating systems.
Way more fast.
Could be.
Oh,
They're
could
both
be,
pretty
I guess.
fast, but containers are considered lightweight because you don't have to keep the whole operating system around like you would a VM because there is no other whole operating system. You just get your own file system. You get your own visualization into the process tree. You can't get out of it using all the little fun proc mappings. Okay? And you get ran in something called a C group. And a C group is a security group addition to the Linux kernel that basically makes sure that when you perform certain system calls, if you're performing them as a container, they get extra scrutiny in order to make sure they're not leaking.
Wow.
So that's why we do things like do system calls in order to map that you don't know about.
Yeah, that's what it's.
Is that enough for you? Okay.
Oh yeah.
Did you know it?
No, not at all. It's, I mean, like, I'm sure, like everything, it's the tip of the iceberg. There's like you can go down the rabbit hole.
Yeah, you can, but the thing is that that's the basic idea.
Yeah.
So, like, inside your, thank you, inside your, do you still have your Docker run BusyBox shell open?
Sure.
Do a PS in there. How many process entries?
There's 3.
Do a PS dash. How many are in there?
Well, I guess I needed to do PSA.
So you had 3.
Yeah, there's 3.
There's only 3 processes on our laptop. Literally, the kernel is saying, container version of the process tree. Matter of fact, IDs that you've got in your operating system for like the core processes that launch the operating system. That means that if your process ID 3 is your shell, then you go out there and take a look at your Docker your host operating system. You'll notice that the Docker container's process ID is not 3. You know, it's whatever it was, 5,000, 8,000, 20,000. And that means that when you're sitting there trying to kill things inside your container, you can kill the PIDs that are in your container. You can't kill the PIDs that you can't even see that are out of your container. And the system calls for the kernel are going to get mapped through a table. And that is the reason that the C groups had to be added in. Well, one of the main reasons that C groups had to be added in, because you had to have some way of saying these system calls happen in context. And so that's where I think the C actually stands for context and not container. Okay, so now when you did your Docker PSA, you saw all of those old processes, including the dead ones, right? Why does Docker continue to keep the dead processes around? Because it's really hard to read log files and other detailed information off of a process that doesn't exist. Especially if everything's being handled with a layered file system and it's completely gone, it could be very difficult to get some information out of it. That still exists to some degree, but there are techniques to remove the old processes, and so you do a Docker remove. Okay? And if you don't want to, say, do a Docker PS-A, you can do Docker remove and then, pass in the parameters for PS-A with a query of your status as exited and so on and so forth. I keep saying Docker. I keep meaning Podman. But quite honestly, Podman is better than Docker in some ways. The original Docker required a root user to launch it because it would use the root PID and the powers of the super user in order to assume all sorts of other users. And so there was always a fear that it would be eventually break it by effectively inheriting from a super user. And so what Podman's initial design was to make what was called a rootless container. Rootless not meaning it's not rooted to something, it just means that it doesn't run as a super user. So with Podman, even if you are not in control of your hardware, like it's company hardware or something, you can run containers as your own user, even if your sysadmin didn't set up some sort of super user account or a systemd thing or something like that. Container prune, Podman container prune, will remove all stock containers. It's an easier way of doing the Podman RM. And so let's just make sure that we have all of our terminology correct. Okay? What is an image?
It's a representation of processes or an application that you want to run.
Yes? Let's clarify it a little bit more. Is an image considered to be running or not? Okay. What's a container? Mark.
To me, in my head, the container is like the instantiation
Yeah,
of the image.
you're right. It's like a running image, a running copy of the image.
Right.
Okay? And the main thing that I'm looking for is images don't run. Containers do. This drives you back if you're somebody who is technology and because you hold something. It does. It holds the image and the read-write layer and a bunch of other stuff. But the point is in this context, containers hold processes, and images are the images. A long time ago, when you used to burn CD-ROMs, you would have an image file. That image file would be what you burnt to the CD-ROM. But when you stuck the CD-ROM in and it started running something, that would be a program.
Right.
And the image and the program were not quite the same. This is borrowing from this kind of idea. The image is the thing that you would, put into the container as the container is built, coming up. All right? There is a daemon, which we may, which Docker's daemon works a little bit differently than Podman's, but there is a daemon that basically is a background service that manages all of the containers. That's how you can do a Podman PS-A. There is a client. The client in this case is whatever Podman wires to, if Podman changed to another program, or it is Podman itself. And then we talked about registries. We've kind of been a little quiet about registries. Every time you pulled an image, it came from somewhere. That somewhere is called a registry. Who has ever used something like Apache Maven? Who's ever used Maven Central? Who's ever used CPAN? Okay. CPAN's a registry for Perl modules. Apache Maven's a registry for Java libraries. Docker Hub is a registry of Docker images.
Cool.
Okay? Well, there's more than several thousand. There's probably over 1 million of them out there now. But the point is that if you have an image that is a popular image, then you'll use its identifier in order to pull it down. And that's where when we pulled the BusyBox image, so Docker pulled BusyBox, this BusyBox got pulled out of Docker Hub. And it's a little confusing because a lot of times we talk about Podman is the correct replacement for everything for Docker, but it's really only the correct replacement for the Docker command on Linux. The repository is owned by freaking Docker, so it's literally still Docker Hub. Podman is just configured to pull from it for compatibility's sake. All right, so now let's pull somebody's static website. Okay? And so what we're going to do is you can pull it first if you want to see it inside your local repository, or you can just run it with this command, in which case it'll pull it on demand. All right? IT means interactive. Okay? What is this RM thing? Well, I is interactive and T is, I think, route to the terminal. This RM thing, TTY maybe. Okay. But what is this RM thing? And this is double slash RM, so it's not two letters, it's a long option. RM. Does anybody know? Remember how when the image stopped, we would have to do a Docker RM in order to get rid of the dead image because it hung around afterwards so you could know that it actually ran? --RM basically says as soon as it stops running, remove it immediately. So I don't have to go back and clean it up afterwards from the list of dead images. Yes?
What kind of stuff hangs around if you don't clean it up? Like I've used Docker installations before and I've never done this before, or I've never done cleanup like this before on containers that I've already exited.
They're just still there.
So, like how?
So do a Podman PS, and you'll see all your running images, right?
Right.
Okay, now do it PS-A, and you see all the dead ones.
Right.
Okay? So to get rid of one of the dead ones, you would have to do a Podman RM and its container ID. And then that would get rid of the dead one.
I saw that, and I also saw like they have a new prune command that'll get rid of all the ones that have exited already.
Yes.
But how do I know how much resources these things are taking of mine?
Well, it depends heavily on how related all of those images are. Because remember how we said it's an immutable file system? Well, every layer of that file system is an independent file. Okay, an independent object or whatever you want to call it, I don't care. It's an independent thing. So, if all of your images are BusyBox images, and BusyBox has like 6 or 7 layers in order to comprise the image, it'll download, you can see it downloading each individual layer on it, simultaneously when you first plug it in. But since all of those are immutable, every time you launch a new one, it doesn't create new resources for those layers, it just reuses them because they're immutable. So it's not that much.
But let's say you have a huge project with a big operating system that's doing a whole bunch of stuff, and
A whole bunch of wildly different stuff too.
right.
Or
I guess maybe I should ask the question: do all those resources show up in top? If I run top, will I see
no, because top doesn't show file systems.
So there's a data, how much data is on the hard drive issue. Is there no resource? They're exited, so they're not actually taking up any CPU time. Is that right?
Right.
Okay.
It's just the remnants of the bookkeeping that they ran.
So we're only talking about disk cruft.
Pretty much.
Okay.
And even then, it'll be sort of optimized to not be overly taking up disk space because it's reusing the immutable layers between all of those images.
Alright, I got it installed.
Yay! Did you get Podman installed or just the OS?
Both.
Okay, cool.
I'm running what looks like Gazelle, but I don't know what it's actually coding.
Start off with Podman run hello-world because if
I
that
did.
doesn't work, nothing else
I
does.
did it.
Okay, cool. All right.
Cool.
So if you'll notice up here it says docker-curriculum.com.
That's where I'm at.
Beautiful. basically what I'm doing is I'm just translating it into Podman from Docker.
Cool.
So, who went ahead and ran this Docker RM whatever static site thing? Because we've been chit-chatting a lot. You run it?
I did, but I don't know.
Okay. It's no
Do,
big
do
deal.
I need to have the other stuff run first?
No.
You only need to run through the other stuff in order to understand what's going on. It's not like it's a prerequisite to make the command work.
Result in alias, no in public search registry to define.
Let's see. P-R-A-K-H-A-R.
That's right.
Oh, maybe it's been removed from the upstream registry. Cut and paste it.
Can I just search for this on the web? Let's see if it's.
It doesn't matter, it's got to pull it. Just like, you can search for a module on CPAN,
Yeah.
but you can't download it using CPAN from the web. You've got to literally download it.
Should I try using Docker instead of Podman?
No, because you don't have Docker installed, besides Podman can pull it too. If it's not there, it's not there for both.
That's what I did last time I was here, was I installed Docker. That works, but that's running as root.
Okay. You've got a registry. Well, Docker has also started to throttle lots of requests.
This Nginx is running.
Yep.
I'm getting did not resolve. An alias and no unqualified, so is that what you got?
Yeah, that's exactly what I got.
Okay.
Did you get the same
This
thing?
is what you have to do. Because Podman has created the need for more registries, you need to specify which registry you're going to. You need to basically put docker.io/ at the beginning of that alias.
Oh, okay.
The alias just basically is a reference to the name. Doc. Yeah, see, what it's thinking is it's thinking that this car is the registry hosting.
Right. It's working.
No, I'm getting used to my copy and paste because I'm so used to Mac.
No problem. So are you back out of group? Back out of group.
This
Okay, then let's do it again. Postgres then. You need copying and pasting from the solution was talking about.
Nginx running for a while.
Mm-hmm. And Nginx is running. It's a web server.
I mean, is it just gonna hang there? Or?
It'll hang there until you hit Control C.
Oh, so I have to, oh, okay. So
Because it's a web server, so it's going to keep running the web server process until something interrupts it.
it's not gonna do anything though. I got
Right.
you. Cool.
So what we're going to do is we're going to change basically, we're going to allow it to publish some ports, and we're going to change its name. So the dash capital P here publishes ports. The dash name indicates what name you want this thing to show up in your real operating system process tree as. And this number is output. Do not type it
Do we have to do the Docker IO again?
in. Yeah, because it won't know which registry to pull it from, so you got to do Docker IO at the beginning of this. And instead of being a Docker run command, it's a podman run. D, this is detach the terminal.
Mm-hmm.
As all the daemons. Tell me once that thing is started. Okay, good. So you've got one running in the background. It's detached. And what we want to do now is we want to find out what port that capital P randomly assigned to. So do podman, I think it's podman port. Oh, podman port, and then you've got to give it the name that you gave it before. Static hyphen site, I think, is what you gave it. There you go. You see the port mapping? So now you can open up these ports on your web browser, and it will route to those ports inside your container. No, you got it backwards. You need to type.
Oh, I see.
Yeah.
Yeah.
Okay, good. So it launched. So now you need to find out what port this capital P randomly assigned the ports to. So do podman port. Okay, and then you got to give it the name of static site because that's what you called it.
So the static site?
Yeah. Hit return. Okay.
Cool.
And so this means that port 80 using TCP protocol inside the pod
Mm-hmm.
is mapped to this port on basically the system's IP address
On operating system?
on the operating system.
Okay.
Yeah, so if you open up a web browser at port 37,669,
Mm-hmm.
it should route to port 80 inside the container.
Ah.
So why don't you do that and see if you can browse this guy's static website.
Cool.
I'm not trying to neglect you, but you just seem to be smooth, sailing along so smoothly. Okay. So in this case, these ports over here are the ports inside the container. These ports are the ports in the operating. Colon for port, yeah. make sure HTTPS is 443 HTTPS.
Hello, doc.
And it's saying that your secure connection failed because your web browser doesn't trust the security certificate in there. So change the port to the HTTP one and get rid of the S. So you're running a web browser inside your container. Your web browser cannot reach your operating system. All of its web pages are inside the container. All right? But your web browser can communicate to the container as long as you use the ports in your operating system that are mapped to the ports inside your container. Now, there's a certain side effect to this that a lot of people don't think about right away. Marco, what's one of the problems if you try to launch two web browsers on the same machine? And two web servers on the same machine?
They can only serve on one port. So if you're doing multiple containers and you're always using the same port, then only one's going to work.
Yeah, if you're doing this the normal way, where you actually have two copies of HTTPD or something like that, then what will happen is one of them will open port 80. No, thank you. One of them will open port 80, and the other one will say, I can't listen to port 80. It's already being listened to by somebody else. Okay? So when you have containers, these containers are not supposed to know that there's something else on the operating system. So that means that you've got to have a way of opening port 80 multiple times. So the way that containers do it is they do it through port mapping. So that means that you can use podman port, and then the name of your container, okay, in order to figure out which operating system exposed ports map to the container's internal ports. Okay? And if you really want to, you can do a Docker run and then just change the name to static site 2. And you can see 2 instances of this static website running. And you can open up both of them by basically figuring out which port goes to which one and just pointing your web browser to that one. This means that you could do things like compare, if you were packaging your website in a container, you could compare both versions of the website to each other in the same machine at the same time, which is useful for something that Marco finds very near and dear to his heart, QA. Marco's like, I don't care about QA anymore. I'm a developer. Okay. Now, what if you wanted a port to not be randomly selected? Because, it's kind of a pain in the butt when your ports are randomly selected, right? You can specify a port mapping. If you take that capital P and make it a little p, you can put the number of the operating system port, colon, the number of the container port. And then that way you can basically say, when I do launch this thing, I want the operating system port 8888 bound to port 80.
If you want me to refer back to a question that I asked you a long time ago.
Sure.
Because I looked it up and found to see how much resources all your images and things are taking, you can use podman system df. So there's a command to look at how much space is taken up.
Okay.
It's this right here. And then also everything that is all the barlib.
Yes.
So there's two ways to find out how much disk user is.
All right. So now let's go ahead and, for fun, has everybody browsed on on port 80 their containerized website?
I did.
Okay, awesome. Go ahead and stop it. You
No.
can stop it by name. Named it now.
Right.
And once it's stopped, then hit refresh on your web browser.
If the website explained the difference between stop and RM.
Stop just stops it and removes it.
So if I do PSA, then it'll still show.
Unable to
That's
connect.
right. If you do PSA, it's still there. Unless you ran it with the --RM, in which case it removes it automatically when you stop it. So if there's a chance you might need it lingering around for, something else, or if it crashes and you still want it, then don't run it with the --RM. And if it's something that's like production, where if it stops, you should really just clean it out so you never run out of space in Charlotte Docker, then you keep the --RM. Okay, so now if you do Docker, if you do Podman images, you'll see we're actually collecting a little collection of images here. All right? It's different than what's over there, but the website will be there. And you'll notice that each one of these images has an image ID tag. You can do image management on them. You can remove an image. Now, it's not the same as removing a exited container. It's actually removing the template that would have used to build the container. Okay? But apparently I thought it was the documentation was going one way and it's going another. Point is that you're pulling these images, and this thing is called an alias. It's supposed to have the extra section at the front. This is a little bit old. This is written by Docker themselves. So just assume from them. And if you don't have it on there at the front, it's sort of another way of doing it. Because there was only one repository, we need to put Docker IO at the beginning of this. You can pull most operating systems offer base images that contain stripped down versions of their own operating system along with all the utilities. So like if I were to do this Docker pull of Ubuntu 18.04 and I were to log in to it by execing a shell into this image, then I would actually get an apt-get configured to Ubuntu 18.04's repositories. I would be able to do things like apt-get update. I would be able to install packages off of their apt into our read-write layer of this image, and it would effectively be a whole operating system. Now, how does a process get turned into a whole operating system? Well, the trick is that this image actually launches systemd. And so it has its whole operating system now. So if you see it as a process, it'll be one process with tons of little child processes all hidden inside the image. Full-fledged operating systems can be used this way. It's not as efficient as VMs, or maybe it's sort of almost as efficient as VMs. It just depends basically on how much stretching you get on the CPU. This way you're creating tons of processes and launching them as one virtualized process because you're really only running systemd. VMs, you're doing it differently. There are pros and cons, but if you start seeing something that doesn't have a lot of running containers, but is taking up tons and tons of space, odds are that they based their image off of a fully fledged operating system image and therefore you're launching the whole operating system as a single process.
Is there any clues that you know of before that you can tell from experience that you know quickly without even having to start it up? You already know that they did that.
Yeah, there's ways that you can actually take a look at the images and see what layers are in them, and the layers are very descriptive of where they come from. And then there are also every image has a from, and it says where it pulled the image from. So anyway, there are two kinds of base images. All right, base images. There are two kinds of images: base and child images. Base images have no parent image. Okay, so they're usually your things that are like operating systems. You'll hear the word Alpine used a lot. Alpine is a miniature operating system. They made it as small as possible because they wanted to use it specifically for containers. So there's like a race for who can have the smallest image. Alpine doesn't always have the smallest image, but they had the smallest image. Everybody thinks that Alpine is small, so everybody uses Alpine. There you go. Child images are children of those base images. They have base images plus extra layers in them. That's where the added functionality comes from. If you were to, say, have a popular application that you wanted to put into a container, generally you would not try to create a base image with your application in it. You would borrow somebody's operating system base image, and then you would make a child image off of it that has your executable in a completely different layer. Official images are just officially blessed. They come from, like, really recognized people, not like, Ed's image. User images are just basically images that you or I would create. Now, if you or I were creating them on behalf of an official organization, it would be called an official image. So now what we're going to do is we are going to make our first image. So what I need you to do is I need you to first make sure that you have Git installed. Second, go into a place where you can have a directory called Docker-curriculum. And third, Git clone this thing. It'll make the directory for you. If anybody's struggling, let me know. Cloning working fine?
Oh, I've got Git on here, and now I just got to get to the directory and then I'll do the clone. And what? Oh,
Clone,
Docker-curriculum.
HTTPS, github.com, and it's still Precard 1989, Docker-curriculum. GIT. And if you're having a hard time typing it or reading it from the screen, remember that you can always go to the same website, Docker-curriculum, and then you can just cut and paste out your browser into your desktop. Clone?
Clone.
I don't want anything. The third static site.
That is teasing. probably already have it planned.
So,
Yeah.
man,
I'm trying to copy and paste.
You're playing around with your copy and pasting stuff.
I got it.
Awesome. Okay, if you can go ahead and change directory into the new directory that was created, Docker-curriculum, and underneath there's a directory called Flask. And Flask is a web application framework in Python. Inside there, you should see a file called Docker file with a capital D. Even though podman is the command that's used on Linux, for compatibility's sake, they kept the name of the config file to be Docker file. Otherwise, everybody would have to rename their files in order to use Linux. So if you go ahead and open that Docker file up in a text editor of your choice.
Which one? Okay, I'm sorry. Which one's the doc?
It's underneath the Flask app directory.
Oh, it's in. Oh,
Yeah. Tab completion should help you out. You do an ls. Docker file. Docker files are like make files for Docker. Of course, it's not make files in the sense of make file syntax, but they are what you use to build Docker images out of. You'll notice something right at the top of it. And what does yours say, Marco?
from Python 3.8.
Okay, that means that it's going to pull this Python 3.8 image. Okay, which we all know that ours doesn't alias correctly. So we'll add that to docker.io/Python 3.8.
so.
Is it always?
So I opened it with Vim, or I just wanted to double click?
Any kind of text editor that you're
Vim will work.
used to. If you're not good at Vim, you can open it with Nano or...
Yeah.
Okay. So you see that from at the top?
Yep.
That's an alias, and we need to specify which repo because Podman won't know how to map that up. So you need to add in that docker.io/ at the beginning of it.
Do they accept any other delimiters besides slash?
The slashes are special.
Beginning of the from.
It's not like a changeable delimiter format.
Oh.
So no, you can't change the
I
delimiter.
hate the syntax of Git and its remotes and its branches because sometimes you do a slash, sometimes they want you to use a space, and then depending on which part of the command you're using, they'll switch them up on you, and it's just annoying.
The image naming pattern, although there are 2 or 3 rules on it where certain parts are optional or not, it's not weird in the sense that some has spaces and some has slashes and some has something else. It's always the same delimiter. Okay, so right underneath there, you'll see worker. What's your worker say?
User source tab.
Okay, fantastic. So that is the working directory for the application that will run.
Okay.
Remember, when you run the image making a container, there is a single process that launches. That process is going to need a working directory. This is the working directory that it will run out of. Okay? You see this copy here?
Mm-hmm.
It's copying all of the files in the outer directory into the image. Copy this directory into the image. Okay? Now that we have all those outer files copied into the image, and you can actually specify actual real file names. You can specify different paths from the source and destination too. Then we will need to, who's done Python development? Pip is an installer for Python. Raise your hand. Yeah. So Pip's an installer for Python. And so after we copy these files in, we're going to pip install the requirements in order to properly have all of the dependencies necessary to run this Flask app. But we're pip installing in which environment? Are we pip installing in the host name? In the host environment?
No.
No, we're pip installing into the container. Now, since we're pip installing into the container, what do you think is going to happen? Will we have a read-write layer in the, not the container, in the image? Do we have a read-write layer in this image? No, what it's going to do is it's going to spin up a small container. Pip install can happen. And after they'll take that read-write layer, it'll export it out and create a new read-only layer. Okay, so we are literally, these commands are literally the next read-only layer. After all of the read-writes are done, then it'll create a new layer. Yes?
You, user source app is on the host, is creating a working directory on the host, or is creating
That's
directory on
the working directory inside the
container.
inside the temporary container that's spun up to build the image.
Okay, that's inside the container, and so we're copying all the outer files into the container. What does the, so it's copies, capital copy space, dot, space, dot, is that what that is?
Yeah, that's basically saying the outside current directory to the inside current directory.
The two dots mean current directory, got it, I see.
Yeah.
Thank you.
And then this pip install, pip is inside the container. So the run is really the keyword. Run basically says run something inside the container. Okay, so like if you wanted to, I don't know, have this in the logging somewhere where you had a last-ditch effort where you check some executable, then you could say something like run MD5 sum. You capture that output to standard log or something like that. You know, standard out. Okay. Now, our application inside that container is going to bind to a port because that's what Flask does. It's a web service type sort of framework. Expose 5000 says port 5000 inside the container needs to be exposed outside of the container. Where will it be exposed outside of the container?
No.
It'll be exposed in the host. What number will it be in the host?
443?
No, we've got no freaking idea because we haven't launched the image that we're building. So it could be there once the image is complete and ran. But this basically is a flag that says this image needs to expose a port. The inside port number
It's
would be 5000.
We have no idea what the outside is.
Right, because we're building the image doesn't know what the outside port number is, it depends on how it was launched.
Okay.
Okay? CMD is command. That is basically, oh, by the way, when we run, this is the command that we're running. Python, and we're going to basically say that we're launching the, inside the working directory, this file app.py. How is Python in there? Well, remember, we used the Python image. The Python people packaged Python 3.8 up very nicely, and it's got exactly this version of Python in it. Now suddenly, some of you will notice some advantages. What's one of the problems with cPanel? Not as an organization, as a technology.
Giant monolith.
I thinking about the background infrastructure. What's one of the problems with PHP? It's a pain in the butt to install multiple versions of PHP on the same machine.
Yeah.
Okay? And cPanel primarily has a lot of utility by being able to launch applications that run on different versions of PHP within the same machine. In this case, we literally install the software stack into our image. So each image comes pre-packaged with the matching set of libraries and executables that should come with it. So this means that when this image launches, it will be running Python 3.8. If Ed's over here and he's got some Python software that for one reason or another can't run on 3.8, he'll use the Python 3.2 image and it will launch on 3.2.
Does Python 3.8, does that image have its own underlying OS image?
Yeah, you use like a very base OS image that would probably be BusyBox related, maybe Alpine or something.
Okay.
But then it would have the Python runtime environment installed right on top of that.
What happens if you load an image like this that already has its own OS, and then you load another image on top of that, and that one has its own OS layer?
So if you're building a base image, it's different. Base images don't have this problem. But they likewise don't have anything inside of them. So you would have to do things like a copy of glibc, you have to get your own LS, your own CP, your own DS, okay? And the way that you build them is slightly different. Nobody starts off building a base image much in the same way nobody uses Linux by starting off with Linux from scratch. Okay? It's one of those things that you do after you know how to build a child image. And we're right now focusing on child images. Okay, so we've got the from, we've got the working directory, we copied some stuff in, we ran pip install. The pip happens to be the Python 3.8 pip. Okay? We're saying it needs to expose a port. We're telling it to launch. Okay? Putting it all together. There's our Docker file. Now, it's time for us to use this Docker file to build a new image. So what we're going to do is we're going to use the command docker build. We are going to build our own image. It's Podman build -T. And I don't put the Docker IO at the beginning of your username. And don't type in your username, literally type in a name that's associated with you. Unless you're just that person. And as you do this, you should see it going through these output steps as it's building its new image.
So we doing the /cabinet?
Yeah. It's just, I'm saying don't put the Docker IO at the beginning because we're not trying to reference the Docker IO repository. You did it right, but the thing is that its pip knows that there's a newer version of Python out there, so its pip is complaining that, maybe you should start off with a new version of Python. But hey, we need compatibility to 3.8, so we're not changing it. At the end, you should see a successfully built, and you should get a new image ID number. Who has seen their successfully built with the new image ID number? 1.
It's working.
2.
Mine's working.
3. That's all we need.
You did?
Now, let's run that image. Do a -P to map that internal 5000 port to some sort of external port that you're not using. Your username,
Right.
whatever you put in there.
Okay.
Then open up a web browser and browse to the external port.
All right, sounds good, then. All right. It's Tuesday. All right, love you, Dad. Bye.
5000 is the internal.
So I need to see the port running on, right?
Well, if you did the -P option, you actually specified it.
That's interesting.
There we go.
I got it.
Okay.
Building stuff on two. Install dash no dash cache colon e dash dir.
Okay. Can you open up your Podman? I'm sorry. Can you open up your Docker file?
Using Vim to open it up.
And then that changes this.
Pretty good. Oh, somehow you probably typed a colon in when you thought you were going to do a colon Q, and so your cache has a colon in the middle of it. The option is wrong.
So no colon.
Yeah, because that's the argument.
I see, okay, okay. I oopsed it.
There you go. At least it was an easy fix.
Make sure it works.
Is your day full of cat fun?
I'm confused why they
Got the one.
the
Yes.
operating system goes first.
It worked.
And then you go to the browser and you use port 4.8.
The port inside the container.
Oh, wait.
Yeah.
Because-
127.0.1.
The crazy people at Docker thought that it would be more important to know which port was free, and then which the free port maps to the inside port.
You can use logos.
I know that at
Logos,
least
colon,
for
4.8.
the first 2 or 3
Oh,
months,
okay.
using
My public does not
backwards,
work.
because I was always thinking from inside the
But
container.
127.0.1 or logos work. Oh wow.
Local host. Colon for it.
Yeah. Nope.
Did you run it with the -P?
That's right.
Okay, let's see. Okay. Back on the terminal. Okay, you built it, but you did not start it. So you need to do a podman run.
Oh yeah. Did I do that?
You did.
Podman run.
Space. -P. Okay, space. 8888. That's going to be your external port.
Mhm.
Colon. Maps to 5000. That's is your name / cat.
You call it admin.
You called it admin?
Yep.
Okay.
Like that?
Okay, yeah, it should be. All right, now if you refresh your web browser.
Good. Yay! Oh, that's so cool.
Every time you refresh, it gives you a different cat.
Oh, does it really?
Yeah,
Oh,
that was the idea. It's a little flask app that rotates through
Oh, sweet!
and a video.
How cool is that?
Okay, so I know that it was a little rough. Most of us don't know anything about Flask applications, except for you. But the point is that you can easily imagine how you could say, copy your sources into something and compile it if you want to make sure that your build chain was inside the container. Okay, if you don't want your build chain inside the container, you could build it outside of the container and then copy it into a compatible container. You know, lots of things you can do. If you wanted to make sure you had a pristine build environment, you could launch a container with all of your build tools in it, copy your sources into a container, build it, okay? Copy the built items out of the container, and then put the built items into a new container. And there's lots of tricks that you can do, and doing this means that suddenly your environment is immune to operating system changes. So there's pros and cons on this. One of the pros is somebody updates PHP to I don't know what it is. Suddenly your stuff stops working in the normal way of things. But if you've got all of your PHP libraries inside your container, this container just keeps chugging along. Downside, you don't actually track security problems. This container can contain security problems for a long time. Now, the security problems will affect everything that's inside that container. But if there are security problems inside that container, remember that container still has a layered file system, it's still operating underneath a C group constraint, and it's still operating effectively in a jail. So, it is more protected than if you have security problems because you don't have the base operating system updated. Okay? Cool. So hopefully you can keep all of your bugs inside the container too. Now, this is talking about pushing. You just built your container. We do not have a Docker registry configured for you to push to. Okay? If you sign up for a Docker account, it will allow you to push things to your Docker account to some degree. They're always trying to get you to, pay for stuff, so I consider that before you get too gung-ho on signing up. But the point is that you can do a login. The login basically will authenticate that you can log into remote registries. And once you are logged in, that basically indicates your authentication is correct. And you can push your application into the registry. That means that you push your version of this little cat GIF application into the registry. I can go home later tonight and go, you know what, I'm just sort of all out of cat GIFs. And I can pull it into my machine and run a copy of it. Not just pull the one that you based it off of, but literally I can pull your image if my login also has permissions that allow me to read your image. Is anybody unclear on that? Sort of like pushing to CPAN. For those Perl people here. Or pushing to Maven Central, for all the Java people here, are pushing to, what is PHP? I know pip is what you use to pull it down, but it's
I think it's called PyPy.
PyPy?
I think so.
Okay.
PHP or Python?
Sorry, I meant Python. No one uses PHP in their right mind.
Actually, the last ticketing system I tried to put together was using.
Yeah, there's still a few holdouts where this stuff is. So the rest of this goes into how you could set up your own repository on AWS and push it up there. But, you know, if you thought that thing, just wait until you sign up for AWS. All right. Multi-container. Who's heard of microservices? Okay. Microservices are small processes, hopefully. That's why they're named micro. And these small processes all have some sort of exposed API. And if you get a bunch of them out there to where one service might call another and so on and so forth, you can actually build whole applications. One service might handle, say, like capturing log files from other services. Another service might say, you know, authenticate that a user has the right password. A third service might say that, you know, an authenticated user can reach these applications. A fourth one might say that, like, as long as the user is authenticated and authorized, then I will give back, the accounts receivable for whatever month that they request, or order food for the next meeting, or whatever it is that the service is. And the idea is you build these services to where they have relatively small domains of control. They each do a specific related group of things. So you would maybe build a service that would maybe handle, say, ordering pizza and maintaining the vendors in which you could order pizza from. But you would not build a service that says, orders pizza, maintains the vendors, and keeps the books for ordering pizza. Instead, what would happen is as that happens, it would send a request off to another one to indicate that an order was placed, and that would update the books. So